What we're going to talk about in this lecture is solving systems of linear equations, but this time by elimination. Now before I get started, I do want to ask you to pull your textbook out, because just like I would if we were in class, I will ask you to pause the video and go ahead and work on some practice problems to make sure you're understanding what I'm discussing. We've already talked about how to solve systems of linear equations by graphing. We would graph the two lines, and the point where they meet would be our solution. We also talked about solving this with substitution, and that's one of our algebraic methods. This was one of your homework problems where you could take this value for x that's already solved for in terms of y and just plug that into your first equation. That would give you a solution for y, and then you'd go ahead and find x. This was another homework assignment which, quite honestly, if I looked at, I would never solve with substitution. I would use the method we're going to talk about today, elimination. But it does give me the chance to point out that no matter which one of these three methods we use, we're always going to get the same solution. So there's no correct way to use. You could have a system of linear equations, you could graph it, you could use substitution, or you could use elimination, and regardless of the method, you're going to get the same answer. When using elimination, what we're really doing is saying, well, we can add, like if I had an equation x plus y equals 2, I could add 2 to both sides, and the equation would still be equal. Well, if I'm saying x plus y is the same thing as 4, then I can add x plus y to the left-hand side of my second equation and 4 to the right-hand side of my equation, and I'll still have an equality. So that's what I'm going to do. X plus x is 2x, y minus y, well that's just 0, and then 4 plus 2 is equal to 6. So I get 2x equals 6, or if I divide both sides by 2, I get x is equal to 3. Of course, I'm not done yet. I need to go ahead and solve for y. I can pick either one of these two equations. I'll pick equation 1, and I'll say if x is 3, that means that y has to be equal to 1. So my solution would be 3, 1. And that's the basic steps for using elimination. Now what I'd like you to do is turn to your textbook on page 324 and 325, and I'd like you to do practice number 1 and practice number 2. I'm going to give you a hint for number 2. You might have to multiply by a -1 before you do your addition. So after you give yourself a chance to go ahead and do those, then come back to the video. Alright, let's go through practice number 1. This is really easy because it's already set up for us. We just add these two equations together. I get 2x equals -4, or x is equal to -2. Once I have x equaling -2, I just use one of the equations, and I'll use the first one, to solve for y, and I'll get that y is equal to 8. So the solution to practice number 1 is -2, 8. For practice number 2, we're going to have to multiply one of these equations by -1 in order to get rid of the 3y. Well, you probably multiplied the second equation by -1, so I'm going to multiply the first equation by -1 just to show you that it doesn't matter which equation I choose, I'll still get the right answer. When I go ahead and do my multiplication and add this together, I'll get that x is equal to 2. If x is equal to 2, I'm going to go ahead and plug in x of 2 into my first equation. Notice I'm using the original equation, not the one that I've already multiplied by -1. I always like to go back to the original equation, and I'll get that 3y is equal to -15, or y is equal to -5. And that gives us a solution of 2, -5. Again, I could check these by taking this solution and plugging it into both equation 1 and equation 2 and making sure that it was in fact equal. Sometimes we'll have to multiply by something other than -1. For example, on example 3 on page 325, we're going to have to multiply the second equation. Well, what the book does is it multiplies the second equation by -3. By multiplying the second equation by -3, we see that 3x minus 3x would be equal to 0. However, I want to do something different. to show you that there's not just one way of doing things. Instead of multiplying the second equation by -3 like they do in the textbook, so you can review that there, I'm going to multiply the first equation by 5. When I multiply the first equation by 5, I end up getting 15x minus 5y equals -10. And then I write down my second equation, and when I add these two together, I get 16x, and the -5y plus 5y add to 0, and -10 plus 10 also adds to 0. And this looks kind of strange, but I can still divide both sides by 16, and I get that x is equal to 0. Even though that seems weird, 0 is just as good of a number as -12, so x can equal 0. Now I need to find out what value of y goes with that x, and I'm going to use my second equation to do that. I'm going to let x equal to 0, and now I'm going to solve for y, and I find that y is equal to the number 2. So my solution is 0, 2. Again, this matches what the textbook has, even though we did it two different ways. Sometimes you'll not have to just multiply one equation by a number, but you're going to have to multiply both equations by different numbers in order to find a variable that cancels out. So what I'd like you to do is work on practice number 3. That's on page 325, and then turn the page and go to page 326 and try practice 4. So pause the video, work on those, and then I'll review them. Alright, let's look first at number 3. I'm going to multiply the first equation by -5, and when I do that I'm going to get -5x plus 15y equals +90. And then I keep my second equation as it is, and then I go ahead and add. And I get 17y equals 102. And when I divide both sides by 17, I get that y is equal to 6. Now I need to find x, so I'm going to use the first equation and have x minus 3 times 6 equals -18. Again, I'm using the original equation. And I get that x minus 18 equals -18, or x is equal to 0. So my solution is 0, 6. For this second problem, I'm going to multiply the first equation by +3 and the second equation by -5. I'm doing that because if I have a 5x and a 3x, if I multiply the 5x by 3, I'll get 15x, and if I multiply the 3x by -5, I'll get -15x, and they'll add to 0. There's not one way to do this. You could have multiplied the first equation by +5 and the second equation by -7 if you wanted to get rid of the y's, but I think in this case it's easier to get rid of the x's. When I do that, I get these two equations. When I add these two equations together, I get 4y is equal to -8. So I find that y is equal to -2 after I divide both sides by 4. So I'll take the y equals -2 and plug it into the original first equation. And when I do that, I get that 5x is equal to 10, or x is equal to 2. So the solution to this problem is +2, -2. Before we finish talking about elimination, I do want to point one thing out. If you're given questions like practice 5 and 6, and this is on page 327, we notice that the second equation has y on the right-hand side of the equation. Well, to use elimination, we always want to get things in the form of ax plus by equals c. This is called the standard form of a linear equation. So I would rewrite number 5 as -2x plus 5y equals 20. And then for the second equation, I'm going to subtract 7y from each side, and I'm going to get this set of linear equations. Let's quickly go through and solve this. I'm going to multiply the first equation by 3 and the second equation by 2. I only have to do a 3 and a 2. I don't have to make one of them negative because they're already of opposite sign in the original equation. So I'll get -6x plus 15y equals 60, and then 6x minus 14y equals -52. When I add these together, I get that y is equal to 8. And if I go ahead and solve for x, I end up getting that x is equal to 10. So my solution would be 10, 8. For question number 6, again, we're going to rewrite the first equation in the standard form. Ax plus by is c. Leave the second equation alone. And now I'm going to multiply the first equation by -3. When I do that, then I will have a -9x and a +9x, and they'll add to 0. When I do that, I have negative 9x plus 9x, which is 0. I have positive 3y minus 3y, which again is 0. Then I have negative 12 plus 12, which also equals 0. Well, remember, if we get a statement such as 0 equals 0, that means that there's nothing I can do in order to make 0 not equal 0. So I'm going to have infinitely many solutions. This gives me a good opportunity to review the different kinds of solutions we can have. When I solved a system of linear equations graphically, generally what I would do is I would plot two lines, and I would find where they joined, and that's equal to the solution. But sometimes I would get a situation where I would have two parallel lines, and that meant there were no solutions. Or I could run into the situation where I had two lines exactly on top of each other, and that's an infinite number of solutions. What this looks like algebraically is, in the case of one solution, I'll get x equaling a number and y equaling a number. And I've just picked two numbers that match the graph that I've drawn, but they could be any numbers. However, if I get a situation where there's no solutions, I'll get something like 2 is equal to 4, or 0 is equal to 8. That is two things that are not in fact equal to each other. If you get that, that means there are no solutions. Or if you get numbers that are equal to each other, like 12 is 12, or negative 1 equals negative 1, or like we just did, 0 equals 0, that means no matter what x and y are, it doesn't change the fact that 12 is always going to be equal to 12. So that's why in this case we have an infinite number of solutions. It's more obvious when you're looking at the graphical solutions, but we need to be able to recognize what it looks like algebraically when we also have these same situations. Again, you can graph, use substitution or elimination. No matter what method you use, you should get exactly the same answer. So if you came up with an algebraic solution that 2 equaled 4, if you graph those two lines, what they would look like are two parallel lines. To wrap things up, let's do one word problem. Turn to page 329 in your textbook, and we're going to look at practice number 8. I'm not going to write out the problem since we all have our textbook, but this deals with admission prices to a high school football game. We're talking about adult tickets and student tickets. So the first thing I'm going to do is say I'm going to let the variable A stand for the number of adult tickets sold, and the variable S stand for the number of student tickets sold. We're also going to note that each adult ticket is $10 and each student ticket was $6. The single sentence, the total value of the 175 tickets sold was $14,450, gives us, believe it or not, two separate equations. We know two things. We know, first of all, the total number of tickets sold was 175, and the value of those tickets was 1,450. Well, the number of tickets sold is simply A plus S. That is the number of adult tickets sold plus the number of student tickets sold. The values for these, however, would be 10 times the number of adult tickets plus 6 times the number of student tickets. And now we've got a system of linear equations. And we're going to solve this using elimination. I'm going to multiply the first equation by negative 10. When I do that, I'll get the following equation. And I leave the second equation alone. When I add these together, I'll get that negative 4s is equal to negative 300, or S is equal to 75. That means 75 tickets were sold to students. To find out how many adult tickets were sold, I'll go back to my first equation, and if S is equal to 75, then I can see that the number of adult tickets sold must have been 100. And that's how you do this type of word problem, which you will have in your homework. So go ahead and rewatch this video as many times as you need to until you understand the material. Email me if you have questions. Do the homework for section 4.3 because we will have a quiz on this first thing in class on Wednesday. And again, don't hesitate to click on Ask My Instructor because I'll be able to help you with a specific problem that you're working on. We'll see you on Wednesday.